Nu får du masa på det, jag måste spela in. Du är en riktig fån, tror jag.
Okay guys, welcome to today's show.
So, today we are going to do the impossible. We are going to try to implement higher order functions in C. And that should be impossible because functions are not first-class citizens inside of the C language. But we will try to make them so. And I'm not talking about using just function pointers. I'm talking about sending real functions as arguments or as return values to functions. And I'm also going to introduce a little bit of object-oriented programming by using methods inside of C. And in addition to this, I will also compose two functions on the fly at runtime in C. So, let's start coding.
Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for yours. Sup guys, welcome to today's show. So today we are going to bend the what's the expression I'm looking for? We're going to bend the realms of possibility. We are going to try to implement higher order functions in C. And I'm not talking about function pointers, I'm talking about really sending the real functions. And this is not possible in C by default, so to speak. No one in the world has ever been able to do higher order functions for real in C. And I haven't, because I just came up with this idea. I haven't even tried it, but I think it might work. So first of all, what is a higher order function? A higher order function is a function that either takes a function as an argument or returns a function. And in some languages, like JavaScript/TypeScript, for example, functions are what's called first-class citizens. That basically means that they are the same as any other variable. So you can send them as an argument to a function, you can return them, you can assign them to a variable, and so on and so forth. They are values, so to speak. That's not the case in C. In C, functions are very distinct from regular values and variables. You can use function pointers, like, for instance, void star f, like this. No, not like that. Like this. And we can set this equal to main, and we can run f instead of main. So this has been possible all along, and we can send these pointers as arguments or return them But that's not really the real deal, is it? No, we want to send the real thing. We want to return a real function, the actual bits of a function. And we want to be able to send them as arguments. So how can we achieve this? Well, if you watched my live stream the other day, I began coding on a quite nifty project, which has not really a name. I call the directory merge. And basically I wanted to find out if it was possible to merge two functions together at runtime in C. And so basically I showed this example. Like if we have the two functions int add1, which takes an int and it returns x plus 1. So this very simple function, and then we have one which we'll call double, also takes an int and it returns x times 2. So basically what I want to do is I want to create a new function which will be equal to, let's call it add and double. I don't like these long variable names. Let's abbreviate it to add and double. And set this equal to something like compose add one and double. And maybe we can't name it double because that's a variable type in C. Let's call it x2. So add and x2. And this will be x2. So basically what I want to do is I want to run the compose function, which composes these two functions, merges them together, and creates a brand new function. And then I would be able to do something like int, I don't know, z is equal to AAX, and we give this number 5, for example. And in this case, z should be equal to 12. It should be equal to 12. And I got a bit on the way. I was able to create an empty function. And I was able to extract the contents of a function and create, based on that, create a new function like this. And I was able to run this without crashing. But I never actually tested if it was able to return something, because I was only trying it on the add1 function. I haven't coded anything for mashing the two functions together yet. So I think we're going to start in that end, because I need to have that compose function working before I can do the higher order stuff. So let's see if I can fix this. Let's try it out first. Let's create an int z x, and let's x be equal to f. So this will run the add1 function. Or it will not run that function, but it will run our f, which is based on that function. And let's print out the value of x. And if this works, this should be equal to 6, right? Let me just find my terminal. All right, so let's see. Let's compile this thing. and I need birch utils. And it's 6. That's pretty nifty. All right, but now to the hard part. Because I want to mash the two functions together, but I want the return value from the one function to be the input value of the second, right? Let me rephrase that. If I have the two functions add 1 and I have the function x2, if I send the value 5 to the function add 1, then I want add 1, the thing that add 1 returns should be the input of x2, right? And then what x2 returns should be the output of the whole thing. So how can we do that? That's a little bit trickier, but I think I have an idea as well. So let's see. Let's start by checking one thing. Let's do an obj dump on B, and let's search for the let's pipe it to more and search for add 1. All right, so this is the raw machine instructions for the add 1 function. So basically, every function returns by putting the value into the EX register. And the input might vary a little bit, but since we are only working with pure functions, and let me define what a pure function is. A pure function is a function that only has one argument, not 0 and not 2, only one argument, and returns a value, so not void, and they need to be deterministic. And what does that mean? That means that if you send the value, send the same value twice, it should return the same both times. So the function should not be affected of global variables or I/O or anything like that. If you send it one value, it should always be deterministic. And no I/O and no other side effects. So we're not allowed to use any global variables. Well, we're not allowed to use the file system or the computer's hardware in some form or another. The only thing is we basically takes an input, does something with it, and returns an output. So this is a pure function, and this is what I'll be working with today. And with pure functions, where is it? I forgot to, never mind. Let's see, add 1. So this function and all functions like it takes its input from this, the base pointer plus 8. And since when you send an argument to a function in C, you basically sends a copy. So we can overwrite this value without affecting anything. So let's end the function before we get to the next, so to speak. We should overwrite this EBP plus 8 value with the output with the return value of the last function. So basically, what's inside of the EX when the function terminates should be moved to this, and then we take the next function. I think that should work. So we need to figure out the machine code for moving into EBP plus 8 from EX. So let's write a simple assembly program. Let's call this temporary.asm, and this will be very simple. All I will say is it should be 32 bits. It should have an entry point called start, and we will just do one single instruction, which is move into EX the value of EBP plus 8, and we want to move a 32-bit value. So it should be a double word value. I think this is right. Save, and let's compile this thing. So we run nasm dot, and let's make it an ELF binary so we can run objdump on it. tmp.asm, and we should link tmp.o to tmp. And then we run objdump-d on tmp. All right, so here it is. We move into EX the double word pointer of EBP plus 8 into EX. So these three machine code instructions. All right. So let's go back to our C code and let's save these in a variable. So int 8 EBP8 is equal to this, and we need to make hex out of it. Like so. And let's also make a definition for that. So define EBP 8len to be the size of EBP 8. And I don't think I need to do -1 in this case. Let's see what we get. All right, so I think we are ready to write the compose function. So what should the compose function entail? Well, we should, it should return, let's see, what should it return? the int 8 empty just returns the bytes. Do we need the length? No, I guess we don't. Let's start that way and see if we need to change it. So it will be compose, and we will take two, let's see, let's take two tuples. So tuple F1, no, or just tuple. So we take two tuples. And if you remember, I defined a tuple as structure that has an address and a size, basically. All right, so how to do this? So we do void, no, not void. We do int 8 compose, and we take the tuple F1 and the tuple F2. And we need an argument, we need a pointer. So basically, we'll work in this one. Let's call it just fun. And fun should be equal to an empty function of size, let's say 64 bytes. And we need to create a couple of tuples as well. So let's call them F1 prime and F2 prime. And F1 prime should be equal to extract. That's right. Maybe we should take void star here instead. Like so, and let's not forget to change this to void star, because then we can just put the function name when we call it. So F1 should extract the first function. F2 should extract the second function. And then we need to have another pointer. And P should be equal to our function plus the header of the function, which is the prelan. Let's see how I did it. Here. So I extracted and fun plus prelan. That's right. And then we will do a mem copy into the char version of P from the char version of F1 prime dot address, and the integer version of F1 prime dot size, I think I called it, right? So we extract the function and we copy it into our new function. Then we increase P by F1 size bytes. So that's the function number one. Now we want to copy our we want to copy our new thing. So into P, we want to copy our EBP8 and EBP8 length. So that will turn the output value of the first function the input value of the second. And then we will increase P by the same amount, EBP8 length. And now we'll do the same with the second function. So we copy into P our F2 address and F2 size. And yeah, I think that might be it. Then we want to return our new function. Is this all? I think so. So let's try it first of all and see if it crashes or not. So let's comment the old main out. And we need to have two functions. Do we have two functions? Let's see. Where is add1? Ah, here it is. So let's copy add1 and create a new one which is called x2. And it doubles this one. And let's create one of these for that as well. Int x2 int. And now we'll create the main. So int main, and we want to have an int 8 fun, and we need a function pointer int star f int. And fun should be equal to compose of add1 and x2. And we also need a void mem. And we'll point mem towards fun, and we'll point f towards mem. And then we will run the f with value 5, for example. And then we want to exit. Alright, so let's see if we can run this without crashing, first of all. We'll compile. Right. Okay, it compiled. That's good. Can we run it without crashing? No, we cannot. That's a little bit annoying, actually. Let me try something real quick before we start debugging this thing. What if we were to do p equals fun plus prelen plus 1? Would that make a difference? Perhaps. Let's recompile and let's run it. No, same again. maybe we need a little bit more space. So let's add 5 to this one. And then we copy the function. And let's add 5 again. And then we copy this thing. And then we add 5. Copy this. And then we're done. Right, let's try it again. Still seg faults. Alright, we need to find out why. So let's reset this thing. Like so. Maybe we should keep the 1 though. Let's recompile, double check that it still crashes. It does. Let's launch GDB. And if anyone knows how I can let GDB save these settings so I don't have to paste them in line by line every time, please let me know in the comments, because I can't deal with all the colors and stuff inside of GDB nowadays. Alright, I want to define XX, which does x slash 30i on the EIP plus minus 20. And let's start. And where do we need the breakpoint? Let's see. Before we execute the function, let's see. Where do we do that? Call EX. This must be it. So let's set a breakpoint there. Let's continue. Let's check the value of EX. So this is where our function lives. Maybe it's, yeah. Alright, so what if we were to do maybe we can just set a breakpoint on that address and continue, right? So now we're inside of our composed function. Let's see what it looks like. A0, no, that's not right. X 30i on EIP. Here we are. So we push EBP, we move EBP, we move ESP into EBP, regular stuff. We decrease the stack pointer by 10. Then we just do a little wait, and then we move into EX our first argument, and we add 1 to it, and then we move the value, the return value, into position -4 on the stack, and then we move from that location back to EX. So this is the content of our first function. Then comes our new instruction, where we move the value did I go the wrong way here? We are moving from the stack to EX. We should be moving from EX to the stack. Though that's not why we're crashing. We're crashing probably because of this one. This looks really weird. Why does it look so weird? If we were to just extract that part, let's say 6i on this address, it still looks weird. What about the rest? Does that look okay? We move this into there. And we move this to the return value. So this is basically the same as what the other function does. But in between we should do the multiplication, right? I wonder if it might have something to do with GDB doing some optimizations and altering our code. Let's try to recompile this thing without those 0, without any optimizations. Does it still crash? Yes, it does. So basically the second extract operation is failing somehow. Let's double check our code. So F2 is equal to the extract of F2. And where are the small functions? I never seem to find them. Here. And they look almost exactly the same. The only thing that differs is this. So why does it fail so miserably? What about, let's try something else. Let's comment out our new main for now. Like so. And let's put our other main back. So this one works, and this one does it against the add one function. What if we were to try to do it against the x2 function? Will it still work? Let's compile this thing and let's run it. Okay, this time this works as well. So there's not really a trouble with the extract function, but rather when we compose them, I suppose. So let's think it through. First, we jump past the pre-lan, and then we copy this function, and we jump past those bytes, and we copy our EBP8. And then we jump past and we copy the F2. So why does it mess up this thing? What if we were to skip this step? No, not there. If we were to skip adding our EBP8, and just take the two functions as is and merge them together, then they will not really work the thing we intend them to, but they should not crash either. Well, they should not crash currently, but never mind. So let's see, we will remove this main again. Let's just see how we did it here. Fun equals empty 64. Essence equals this. P equals fun plus pre-len. We mem copy. Mem is equal to fun. F is equal to mem. Yeah, we do the same thing. Alright, so add one, x2. Yep, let's check it out. So now we're only interested in if it crashes or not. It does not. Alright, so it's something with our EBP instruction. Perhaps it translates to something else in combination with the other surrounding machine code instruction. That's one possibility. And anyway, we still need to change this code a little bit because we are moving the wrong direction, aren't we? We want to move into the stack from EX because the return value is in EX and we want it to be put as an input value to our next function. And let's curry this with a little bit of no-ops. Perhaps before as well. Let's do 2 in front and after. So let's run NASM again and LD and obj dump our TMP. Alright, so it looks basically as one would expect. But just to be sure, let's add those to no-ops as well. Just to create some space. So let's just change this line, the new one should be int 8 ebp8 is equal to this. Remove this stuff, and we need to add this \x thing is. Like so. And let's see if we get another result. So let's just recompile. Right. And let's see if it crashes. It does not. It does not crash, ladies and gentlemen. Does it work? This is the very exciting part of this. Let's print the result, shall we? So let's create an int x. X is equal to this, and then we print the value of x. And what do we want it to be equal to? 12, right? And let's see if it is. In that case, we have already pushed the boundaries of the C industry. It's 10. That was not expected. 10. I think we need to analyze the assembly. So let's go back into GDB and let's create script, define f, and we want to I never seem to remember this right. Alright, so we set the target exec to nothing, we set the target exec to our B, and we set the symbol file to our B. So this is basically to reload the new binary after we have compiled. So we run the F, and we start again. Delete breakpoint, yes, we start again. Yes, from the beginning. Alright, so let's do XX, and we find our call to EX. Continue in there, and we check the value of EX, and we set another breakpoint there. Continue, and we need to do X30I on our instruction pointer. Alright, so this is our composed function. First we have the header, nothing spectacular about it. We have a no-op, and then we have our add1 function, which goes all the way, let's see, move EVP, move into EX. Let's see. So here we move into the stack from EX. So that should basically be fine, right? But it still looks a little bit weird, doesn't it? No, maybe not. And then we move into EX from did we forget to include our... Yeah, I think we did. I commented it out before and I didn't insert it back. All right. Things are starting to make sense. Let's see if it still works without crashing. No. Why does that very simple instruction fail so miserably? Miserably. Let's go back into GDB, reload, delete breakpoints, start, and XX. We go here. We break here, continue, and we run X30 on our EIP. Alright, so here is our finished composed functions. And now we have some no-ops so we see what's going on. So this is the header, then we have a no-op, then we have the entirety of the first function. And then we have some no-ops, then we move into the stack from EX. Exactly as we specified. And it is the same location. Then we have a couple of no-ops. Then we add some really funky looking things. It's pretty weird. When we don't include this stuff, all this looks correct. But when we add this, it corrupts this stuff down here. Why is that? Why is that even possible? Add byte pointer EBX blah 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 blah. If we were to do X6i on that address, it looks weird. What if we were to do it on the next address? Move EX, D-word pointer, add EX, EX. Now it looks right. So it must be some kind of off by one error. So how do we fix this? Basically, if we look at the hex representation, of this point in the program, there is a 0 byte there. A 0 byte. Memcopy should not have a null terminator. And this is in the beginning of the function. So maybe we should copy from this address -1, but why should this be -1 and not this? That doesn't really make sense, I guess. Wait a second. Maybe when we do this, will it add a null terminator at the end? It's possible. In that case, we should do EBP len -1, right? Maybe we need to put this inside of parentheses just to be sure. And then we need to do the same thing here, I guess. Yeah. Let's try this. Huh, it works. Look at this. We have succeeded in creating a composed function at runtime in C. Fabulous stuff. All right, so where do we take it from here? We want to create real higher order functions. We can send function pointers as arguments, but that's not really fun, is it? What we want to do is send those functions for real. And since one of the last C standards, we are able to send not just pointers and integers as arguments, but also structures. And I mean the entire structure as a value. So let's create a structure for a function. And how would that look like? Well, let's do struct s function, and let's see. So what does our functions consist of? Well, basically, we need to have the opcodes of the function, basically. And that are int 8. So let's do int 8 machine code. And let's use 64 for this. We will type def struct s function as function. So let our compose not return an int 8 star, but let it return the actual function. And how do we do that? We need to create one of these things and copy our machine code into it. And so basically we'll just do something like this. We will have a function ret, and let's see, we want to do a mem copy to the address, to the char representation of the address to ret, and let's see, we want to copy from fun, and the size in this case is 64, like so. I think this is right, and then we'll simply return ret as is. Maybe we should also include a method. Why not? So let's do an int. Let's call this call. It takes an int. And ret dot call should be equal to, what should it be equal to? Should be equal to itself, basically, almost. But if we send this as a value, it will probably copied somewhere on the stack in the calling function, which means that this address will not be valid. Maybe we should just leave it from here, and inside of main we can use it. So let's remove all this noise. We don't need the mem, and we or do we? Yeah, I guess we do. We don't need this though. And instead of setting f equal to mem, we will set our function, and let's redefine this as a real function. We'll set our fun.call equal to mem, and then we can just do fun.call, I guess, just like a method on an object-oriented language. I'm not sure if it's possible to use that syntax, but let's try it out. Does this compile? No, it does not. Expected identifier or blah 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 before void. Star. Right, so this second one is equal enough to fix. We will just set this equal to the address of fun. But why does it complain about the first one? I don't think the word function has a specific meaning inside of C. Right? typedef struct s function to function. Struct s function. And this, oh, maybe it needs a name. It still does need a name though. Alright, let's try this out. Compile, compile. It compiled. Does it run? It does run. So, ladies and gentlemen, what have we achieved today? Well, we have achieved being able to create functions at runtime on the fly inside of C and compose two functions together, the real bits of the functions. We have also implemented object-oriented programming in C by allowing to have methods on our, well, objects. And most interesting at all, we have been able to create real higher order functions in C for the first time in human history. And the higher order function in question is our compose function, which returns a real function as an argument. So, that's a lot for one episode, I think. And I hope you really enjoyed this episode because it's really special. So please like and subscribe. And please let me know in the comments if you like more advanced content like this one. And thanks for watching and thanks for today. What's up, guys? Before we begin, I'm going to show you how you can install burst utils, my library with the utility functions. So you can go to the repo and the latest version and download the zip file. So you unzip that file and then you just go into the directory and you run make. If you get an error in line with if you get an error like C2X is not available, you need to upgrade your GCC. And then you need to run sudo make install, enter your password. And if you get an error which says something like no such file or directory, that means that your library directory is wrong. In that case, you run ldd bin ls and you take this string right here. Then you edit your make file and you go to the lib directory and delete what's already here. And then you just paste this in and then you run sudo make install again. And you can try, you can test if burst utils worked by creating a C file where you include the burst utils.h. You create a simple main function where you declare an int8 variable like x and set it equal to 5, say, and then you return x. And you compile this by doing gcc ac-o, and then you add burst utils to the end. And if this compiles and runs, then everything is working. So let's begin our regular episode. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support.